Thank you everyone for being here. I'm Raghu and I'm in the AI product team at Plaid. You probably heard the phrase AI powered applied to just about everything at this point. So I want to be really specific today about what we mean and why it matters to products you're building and the decisions that you're making. The financial industry is shifting to intelligent experiences that are more personalized and adaptive. Budgeting tools that anticipate cash flow gaps, risk models that adapt to changes in income, and fraud systems that respond to emerging threats in real time. But these experiences are only possible if they are based on specialized models that deeply understand financial data. That's exactly what we set out to build at Plaid. Today, I'll walk you through how Plaid built our foundation models and how those models can improve our products. So let's get into it. If you ever tried to build something useful using financial data, you likely find it's messy, inconsistent, fragmented, and highly contextual. And depending on the use case, you'll need different levels of granularity, which means taking the time to standardize and interpret the data across accounts, across users, before you can do anything meaningful. Here's how that looks in practice. When transactions hit your bank account, what you often see is an institution specific format with an abbreviated merchant name or some cryptic descriptor. Take a look at the left side of the screen. What is that? If you know what you're looking for, it's a grocery purchase at Trader Joe's. But a general purpose AI model reading that string is going to miss that context. And that's just one transaction in isolation. Complexity compounds when you want to provide services that look across accounts, institutions, and over time. Financial behavior unfolds in patterns, sometimes clear, sometimes very subtle. A single transaction tells you very little, but over weeks or months, these patterns reveal income stability, lifestyle changes, financial stress, or early signs of fraud. That context is what powers better risk models, underwriting, and fraud decisions. The hard part is separating signal from noise at scale. The signal is there, but it's buried deep in the messy descriptors, institution specific formats, fragmented accounts, and patterns that only become visible over time. Traditionally, this has been handled by building a lot of specialized models and systems. One for categorization, one for merchant identification, one for income, one for fraud. Each model solved part of the problem, but had to relearn financial context from scratch. The opportunity with foundation models is to change that. Instead of rebuilding context for each product, we learn from a shared representation of financial activity, what transactions mean, how accounts behave, and how financial patterns evolve over time. That's what our foundation models are built to solve. Historically, a lot of financial AI has been built use case by use case. At Plaid, we are building a small set of shared foundation models that are trained specifically on financial data and using them as a common intelligent layer across our products. Instead of rebuilding financial context for every use case, we learn a reusable representation of financial activity once and then apply it across many downstream capabilities, right from categorization and entity recognition to fraud, to risk, to underwriting. That only works if the model is trained on financial data that is broad, diverse, and representative of real accounts and consumers. And this is where Plaid has a distinct advantage. Our network allows us to see financial activity with a level of breadth and depth that is very hard to replicate. We built two complementary models that reflect this. The first one is a transaction foundation model. It focuses on understanding individual financial events, what a transaction represents, who the merchant is, what the category is, what type of account, and other context specific metadata. The second is our sequence foundation model. It looks beyond individual transactions and learns from behavior over time. The order, the timing, the frequency, and the structure of financial data. This includes things like changes in deposits, spending patterns, transfers, balance, repayment activity. Together, they give us a richer representation of financial activity, not just what happened, but what it means in context. Let's start with the transaction foundation model. The primary job of this model is to understand what an individual financial event actually means, even when the description is abbreviated, inconsistent, or difficult to interpret. Instead of training a model to memorize labels, we train it to learn transaction semantics. Given a messy transaction descriptor and its surrounding context, the model should learn what the financial event actually represents. To do this, we built a transaction interpretation pipeline. It takes transactions, extracts key entities like merchant, location, payment type, and combines that with context like amount, amount types. And when something is ambiguous, the system can bring in additional context. The output of this pipeline is a plain interpretation of that transaction. We then train the model by showing it pairs of transaction and interpretations and ask it if the description matches the transaction. Each interpretation and transaction form a positive pair. We also show plausible but incorrect alternative interpretations that look reasonable but mean something financially different. Over time, the model learns to tell the difference. A salary deposit gets pulled towards concepts like payroll and recurring income, and away from concepts like refund or one-time transfers. Repeat that across enough examples, and the model builds a structured understanding of what financial event actually mean. Once the model has learned that representation, we can adapt it to downstream tasks such as categorization, entity recognition, semantic search, income detection, fee classification, with much less task-specific modeling work. The key idea here is that the transaction foundation model is a shared infrastructure, and every product built on top of it inherits those improvements automatically. By understanding individual transactions is only half the picture. The transaction foundation model helps us understand the meaning of each financial event. But if we simply average those transaction embeddings together, we lose the most important part of the story, the sequence. We lose what happened first, what happened next, how much time passed between those events, and how behavior changed. Timing matters. A paycheck followed by rent, utilities, and saving tells one story. Irregular deposits followed by an overdraft, fee, and a short term borrowing tells another. A sudden change in spending or transfer can be more meaningful than any one transaction on its own. So the sequence model starts with a time-aware event embedding. Each transaction carries its own representation, but we also encode temporal context, the order of the event, the time gap between events, and the cyclical patterns like day of the week or time of the month. That matters because two transactions 5 minutes apart mean something very different from two transactions 5 weeks apart. Those time-aware events are then passed into a sequential backbone using a transformer-style architecture. The goal is to produce a global embedding that is able to summarize broader financial behavior. The important difference is that each event is no longer interpreted in isolation. A transfer, a fee, or a deposit can be understood in context of what came before and what came after. For pre-training, we focused on two self-supervised tasks. The first is a contrastive predictive coding. The idea here is useful representation of someone's financial history should be predictive of what's likely to happen next. The model looks at a sequence of past transactions and learns to identify the true future transaction from a set of negative candidates. That forces it to learn user-specific patterns, not generic transaction similarities. The second task is a replace token detection. Here, we take a sequence of transactions and intentionally corrupt it by swapping it with transactions from other consumers. The model's job is to identify which transactions do not belong to that sequence. That is especially important for use cases like fraud and ACH risk, where the signal is often not a single obviously bad transaction. The signal is the transaction that looks wrong in context. Wrong timing, wrong merchant, wrong amount, or wrong relation to the rest of the financial history. Together, these tasks train the model to understand both prediction and order. It learns what kind of events tend to follow other events, how routines form, and when behavior starts to deviate from a normal pattern. That unlocks a different class of use cases. For risk, that means identifying signs of financial stability or stress that are not visible in static snapshots. For fraud and ACH risk, surfacing behavior that doesn't fit in the expected sequence or timing of activity. For underwriting, a more dynamic view of income, spending, repayments, and liquidity over time. So, the sequence model is not just asking, what does this transaction mean? It's asking, what does this financial behavior mean in context and how is it changing? We are still testing and learning with the sequence foundation model, but early results suggest it has a potential to unlock a much more responsive and accurate understanding of financial behavior. So, we talked about how the models work. Now, let's talk about what they enable. These foundation models are becoming a shared intelligence layer across Plaid. Our transaction and income products are already benefiting from this today. We are expanding the same approach across our product suite. That means faster product development, stronger model performance, and improvements that compound across the platform as the underlying model gets better. The transaction foundation model is already in production and generating measurable improvements across Plaid products. Most recently, we saw an 89% precision and a 93% recall for income classification. That means significantly better identification of a person's income sources and amounts. The single most important factor for most lenders and underwriter decisions. Loan payment detection improved by 14%. That's more reliable identification of on time payment, which directly affects how accurately you assess repayment ability. And back fee classification improved by 22%. That's the last one matters more than it might sound. Fees can be an early indicator of risk. Overdraft and NSF fee can signal financial strain, while late fee reflects missed payments. Getting that classification right means catching those signals early and more consistently. For the sequence model, early testing shows that we are able to detect 26% more high risk ACH transfers without increasing the number of transactions we are flagging or declining. For risk scoring, at a 70% approval rate, we are able to reduce an additional 12% default for lenders. So, let me bring this back to why it matters to you. Financial systems are evolving towards intelligent experiences. That shift requires AI understand financial data at a deeper level. That's what we are building at Plaid. If you want to go deeper on how these models power specific use cases, whether that's cash flow underwriting, fraud detection, or risk assessment, I would love to connect. Reach out to our team and we'll show you what it looks in practice. I want to thank you all for joining today. Now, maybe we'll take a few questions and hear from our audience. Let me go. Okay, this is an interesting question. Are these models replacing traditional ML and rule based systems? Not entirely. In many cases, foundation models work alongside existing systems and rules. The difference is that these models provide much richer understanding of financial context, which improves accuracy and reduces the amount of time that is needed for manual feature engineering kind of a work. Will I need to do additional integration work to benefit from these models improvements over time? The answer here is going to be generally no. The foundation models are part of the shared intelligent layer that will power Plaid products. Any improvements we make to these models will flow directly into the insights and signals that you're already consuming with minimal to no additional work. That's all the time we have for today. Again, thank you everyone and have a great rest of the day.